Good morning, everybody. Welcome to the ICT Educator webinar series. I'm Steve Wright, Statewide Director for the California Community College ICT sector team. And if you visit our website, you'll actually get to see the pictures of our entire 10 regional directors who work in every part of the state with the different colleges there. And on that website, you'll see all of our ICT pathways materials, as well as prior ICT webinar, educator webinar archives. And recently we've had some pretty interesting webinars. I think it's the next slide, Nicole, that are there in all these different topic areas. And as you go and look at these, you'll find that they're all video recorded. The video is chapterized, so you can find the part that you're looking for. There's a transcript provided, as well as the materials for presentation. All of this is very helpful, whether it's in the classroom or writing a grant or this, that, or the other. So our goal here is to make this a valuable tool for you. Coming up in the next few weeks, we're going to take a look at the Google IT certification and how that effort is going. Came out of left field and is taken over by storm, and we have a lot of people asking it because the branding is so powerful. And we'll be looking at how colleges can implement that on their campus if they choose to do so. We'll also look at the CAE designation and what it takes for a college to get that and how much time and effort it is. And so people who are thinking about doing that for their college can an eye at that. And then we're going to take a look at something that's pretty interesting, which is how come some community colleges have higher rates of transfer to computer science to the CSUs than others? And what best practices are they employing that make that happen? We had a researcher look into that. She's called all the colleges and talked to them, and she's put together a really interesting study. Today, I'm very excited that Laura Chappell is going to be with us today. I've seen her present a couple times at the ICT Winter Conference, and as I joked beforehand, once you realize what she does, you quickly turn off your cell phone and all your IP things, because she has the ability right up there from the podium to show everybody else exactly what you're doing. And Laura is going to take us on an interesting journey today, and without any further ado, Laura, I'll just turn it over to you and let you grab the screen and bring us all up to speed with cybersecurity and Wireshark.
Excellent. All right. Can everyone hear me all right? If you don't mind, just put something in the chat window. Let me know that you can hear me. Steve, can you hear me all right? Okay. Great. Thanks. Well, I'm very pleased today to get a chance to talk with all of you. I think it's phenomenal. Oh, I hear children in the background somewhere. So if you could mute your audio, those of you that are hopping in here, that would be great. Because my kids are grown and I don't want to hear that anymore. But I think it's great that this is recorded and that the transcript will be done for you, and also that you will have time codes for different spots in this video. I have a lot to go through. Right now, you can see, hopefully on my screen, I've got Wireshark showing, but I also have 3 slides, and that's it. If you need to reach me after this presentation, I have my email on this slide here, laura@chappellu.com. Please make sure that you connect to me through LinkedIn, because I do a lot of communications through LinkedIn with folks. But this is what I want to go through in this session, and there's a lot in here. We're going to start out with just Wireshark and how we get to the source code. And I'm thinking of Wireshark from the perspective of an educator, things that can inspire those students, the cool things, the sexy things, the things that really can excite that person in front of you when you're trying to explain this stuff. Because a lot of times people tell me, and I don't know if I believe it, but they tell me that packet analysis can be boring. And it really is not. It's fascinating what you can learn. And I'm going to take you in a moment. I'm going to show you how unique the relationship is between your Chrome browser and the Google website. It does something that no other browser will do when it hits an HTTP server. So I'm going to do a live analysis for you and just show you that. It's something you would not know unless you'd picked up the packets. I will talk a little bit about the importance of knowing the protocols, and I'm going to show you a great poster that you can put on your classroom wall that I developed going through the internals of TCP. I will take you through some resources for cybersecurity analysis, where you can find some trace files of malicious communications, where you can find some scenarios to run through. And at the end, I'll show you a scenario and take you into one. I'll show you my best practices for annotation, and I'm going to give you a trace file that's heavily annotated that deals with a malicious redirection process. Now, many years ago, people began talking about the death of analysis, the fact that these tools that we use to tap in and listen to network communications, they basically were going to be useless because, first of all, we had switches going in and the traffic wasn't flowing everywhere where it used to be in a hubbed environment. Okay, we got past that because now we can span switch ports. We have these things called taps where we can listen in. But the other thing that's come up in the last few years is the death rattle again. People talking about the death of analysis because all the traffic should be encrypted. So what are we showing our students? We're showing them just TLS encrypted traffic. So what I'm going to do is I'm going to take you through the decryption techniques, and I'm going to give you the instructions to allow you to decrypt traffic before you start running Wireshark, so that when you pick up that traffic, you get to see it in a decrypted format. And I'll give the instructions for Mac, Windows, and Linux to set that up before you start the capture, and now everything is clear to you. You have the pre-master secret built in. So I'm going to set up my system from scratch and show you step-by-step how to do that. I'm going to finish up with a scenario for teaching network forensics. It is a harassment case. We have an email that's being sent to a teacher. The email is a self-destruction email, so it doesn't last for long, but we'll catch it on the wire and we'll take a look at how we can find out who the perpetrator is. And then I'm going to wrap the whole thing up with an invitation to not a party per se, but a free virtual conference I have coming up, where I am bringing in all my friends from the industry who've been teaching for years and people who've made products. You know, the guy who created Tor. I've got the guy who created Security Onion. I've got, you know, just some amazing people that are coming together online to offer this free virtual conference. And I want you to invite all of your students to join us, because we have a student union booth where we have some amazing things that we're going to give away. So I'll finish up with that. So let's pop over to Wireshark. Now, Wireshark is an open source project. It's considered one of the most successful open source projects of all time, with well over 1.5 million downloads per month right now. So it is everywhere. The version I'm on is a 3.2 version. Wireshark does an auto update feature for you. It's got the auto update for Mac just went in. If you wanted to download the latest version of Wireshark, I'm going to come out here. You can simply go to wireshark.org, and you'll see a download button there. And when you click the download button, what's interesting is that Wireshark will tell you what installer you should download. And the way Wireshark's website knows that is because when I hit that site using HTTP, I identified my browser I'm using, and I identified the operating system on which I'm running. And that's how that site knows to recommend the Windows 64-bit installer. So as you get into Wireshark and you bring it into your classes, you're going to have students who are coders. You're going to have those students that want to know the underside of Wireshark, how it does what it does. Why does it mark something a certain way? And while I'm on the Wireshark website, I want to take you to a location that you should point those students to. If someone wants to understand how Wireshark does what it does, they can go up to Develop, and they can actually browse the Wireshark code. They can see the whole open source code of Wireshark. It's maintained on a Git repository. And when they come in here, these students that love to tinker at that level, because you know you'll have those students that they'll be way ahead of the rest of the class and they need something extra to do. You can point them to this location, and when they come in, I'm going to show you this subdirectory to send them to. Here's our GitHub repository for the current version of Wireshark. And in here, there is a directory called EPAN that people don't seem to know about, but it stands for Ethereal Protocol Analyzer, which is what Wireshark used to be called. It used to be called Ethereal. If you go into the EPAN directory, you will see a subdirectory called Dissectors. Now, this is the power of Wireshark. Wireshark's ability to look at a TCP header going by on the network and pick it apart and pull apart all the different fields in there. I'm going to do a find in here, and I'm going to look for packet-tcp.c. That's where I would point these students that are advanced. I would point them to that packet-tcp.c file. That's the dissector for the TCP header. And as they look at a TCP header in Wireshark, they can look through this dissector and read, oh, look, there are the fields I recognize. I know these different fields showing up here. There's Windows scaling in there. Here are the TCP options field. And it gives them a sense of being able to understand what's going on under the hood in Wireshark. All right, so that's where you get to the dissectors and the master code in Wireshark. But what I want to do is I want to show you how powerful Wireshark is for understanding what's going on a network. Now I'm going to do a live capture, and what I'm going to do is I'm going to bring up Chrome, my Chrome browser, and by default Chrome is going to hit the Google website. Now I do recommend that before you do any sort of a browsing and you're trying to capture your traffic, that you go out to the command prompt, running it as an administrator, and you clear caching items, such as your ARP cache. So I'm just going to type in ARP-D, and you clear your DNS cache. So I'm on a Windows system, so it's ipconfig, and then //DNS. Now I have a whole set of notes that go with this presentation, and those two commands are in my notes. But this is typically something that I do before I'm analyzing my own traffic when it has to do with web browsing or anything that might generate DNS to get to a target. Just going to move this window aside because we'll do the same function again in a bit. I'm going to start Wireshark running, and you can see I have a lot of connections here. I'm connected by Ethernet. So I'm going to select my Ethernet adapter. Now, what you're seeing right now is the background traffic of Zoom. So if I were trying to analyze how Zoom works, I can see that Zoom uses UDP, and it does that because we don't have the latency issues that we have to deal with TCP, the setup process, the overhead of TCP. My system also has Dropbox on it, so every once in a while I'll see a Dropbox sync take place. I have McAfee. It'll go in and check to see what the latest virus detection database has. I have lots of background things that are taking place, but I'm just going to let this run for a moment. And now I'm going to start up Chrome. That's all. All I want to do is analyze what I did right there. I'm going to close that Chrome browser, and I'm going to stop Wireshark. What I'm interested in is finding out the moment when I hit that Google website. So I'm going to put in what I consider a very lazy filter in here in Wireshark to say frame contains, I have to type it right, quote, and I'm going to put in Google. And what it's showing me are the moments that I'm hitting the DNS server to resolve the name Google. And we can see that I have some secure communications taking place to a Google server. When people are starting to learn all of this stuff and starting to look at the traffic, one of the things that gets the students a lot of times and really turns them off is the fact that you have all these different IP addresses in here, but we don't know necessarily who everybody is in the whole thing. I can tell that that's going to be a DNS server I'm going to when I make a DNS query. But we can actually turn on name resolution in Wireshark to help us figure out to whom we are talking. I'm going to go ahead and turn on name resolution by selecting Edit, Preferences. I'm going to go under Name Resolution and say, I want Wireshark to resolve the network IP address. I'm just going to turn that on. By default, Wireshark is going to look inside my traffic that it captured to say, oh, can I just figure it out based on that? And if not, it will go out and ask a DNS server for a name. Now it should make a little bit more sense as we're looking at the traffic, and I remove that, excuse me, I remove that filter in a moment. We can see now to whom I am talking. So there we go. This is all communications going out to Google. Now we can see that there are different Google servers, but check this one out right here. We are going out to the Google website. I'm going to pull that one conversation. That is the loading of the default Google page. I'm going to right mouse click on that packet and say, I just want to follow that one UDP conversation. This is what we do to load the Google website when you're using a Chrome browser. It does not use HTTP. Every other browser in the world that hits google.com is going to use our standard HTTP to get there. But because Google released their own browser, they can do anything they want to load that page. They can use any protocol at all. Chrome will always load the Google web page faster than any other browser in the industry because it doesn't use TCP, doesn't have the overhead. They have it all running over UDP, and it was a brilliant, brilliant idea. You would never know that unless you picked up the packets. And this process here came up because people would ask me, they would say, how come this runs faster using this browser versus this browser? Why is this website loading faster when I do Safari versus when I do Firefox? And it gets me in my lab sitting here going, well, I don't know. Let's see the difference in the way the browsers behave. And that's when this came up, that obviously Google had created a whole different way to load the page. It's not our standard HTTP. So I think that's a really interesting example of why we capture, why we capture the traffic, to really understand what's going on the network. You have to understand the protocols. You have to understand, all right, how does ARP work? How does DNS work? What about when we do TCP? How does that handshake work? Because the performance of the applications are based on how well the underlying protocol stack works. So many times I'll go to a customer and they will complain about an application. Everyone's pointing at the application or the server, and it turns out it's not where the problem resides. The problem resides at TCP. There's a problem with TCP behavior. Okay, one of the biggest problems with analysis these days is this idea that we've got this encrypted communication. I can see that, I know Zoom is doing my audio video feed through UDP, but it does its command channel through TLS. It's all encrypted traffic. And again, I'm going to show you how we decrypt traffic so we can see what's happening there in just a moment. As far as resources and teaching some of this stuff, I did want to take you out to the Chapel University website, my website, because I have some supplements that I want all of you to download and give out in your classroom. It's under my blog, and there is a poster. If you would like us to send you the poster, oh, my office is going to hate me for this, but if you would like me to send you a poster in a tube to put up in your classroom, poster requests, you can send me an email and put poster request up in the subject line, and then just make sure you give me your mailing address. And I will make sure from our office, we will send you a poster or a set of posters. If you want 10 posters or whatever, just let me know and we will put them in tubes so they're not all wrinkled. But if you look in the blog area and you want to see what this TCP poster is about, we released this poster last year, and I have another poster I'm working on right now in this architectural series. But this poster goes through the TCP header and the options of the TCP header. And it's available right now in a PDF format, so you can just download the poster if you wish to and take it to a local print shop like a Kinko's. And I think they'll print it and put it on foam core for $18 or something like that. But this is a great resource to have in your class when you're teaching the protocols. Now, I've got another set of posters that are going to be releasing this year, all along the same series, so that there's a reference for people on how these protocols work and what are we looking for. Some of the protocols that I'm working on, or some of the posters I'm working on, have to deal with problems in communications. So that's a resource I definitely want all of you to go out and grab. There's another resource I want to point you to also. Let me get back out here. Out on my website, I have all of my trace files I use available for you to download and use in a classroom. The way you would get to my master trace file set would be to go to Chapel University and More, and then go to Trace Files, and you will see there are the FTP instructions for you to download my trace files. Now, the student portal we have is for a separate set of training organizations that actually use my courseware and do training. Everything that's in that student portal is also down here. In fact, the master set is what's down here. The student portal has a small subset for a specific class. But this is where you can get my master set of trace files. They are accessible through FTP, so if you have a firewall that's blocking FTP, you're probably going to have to open that up. And when you log in there, you will see there's my master set of trace files. When you're teaching cybersecurity classes, I want you to focus on my trace files that begin with the letters SEC. Those are all of my security-related trace files. I'm going to go ahead and open up one of those trace files right now. This one called sec-getsplendid.pcapng. Go ahead and open it up with Wireshark. This is a trace file I do recommend that you show to your students and have them go through the process of analyzing it. Let's see if it opened it up with Wireshark yet. That's interesting. I only have one instance of Wireshark running right now. I should have a second instance. I'm just going to go ahead and manually open it up from in here. No, I don't want to save those previous packets. Okay, there we go. So this trace file is heavily, heavily annotated. I have lots of notes in a lot of my trace files. So if you were to download some of my trace files, the first thing I want you to do is I want you to go through, and I want you to go in the bottom left-hand corner, and I'm just going to make a note. In Wireshark, go to the bottom left-hand corner here, and on that status bar, you're going to see a little button that looks like a trace file image with a pencil on it. When you look down here in the bottom left-hand corner and you see that little icon, I want you to click on that. That's how you will see not only my annotation for the trace file itself, but also you will see my annotation that I put on individual packets. When you're teaching a class, this is a way of getting students to tell you they understand a trace file. Have them annotate it. Have them put notes in the trace file to say, aha, I can see that the client tried to go to site ABC. A question came up. What is the FTP username and password for WiresharkTraces.com? That is shown when you go to this page, the traces page. I have the username there and I have the password there for you. Just want to make sure everybody can get in there. All right, so here we have an annotated trace file, and this trace file is really cool because I was trying to demonstrate to a client what a DNS name error would look like. So I thought, I'll just type in some crazy name in my browser, some crazy domain name in the browser, or some crazy URL, and I will hopefully get a DNS error response that comes back. So I typed in www.asdf. Now, don't do this on your browser because you're going to end up on a malicious site. You're going to be redirected through all these malicious sites. But that is what I typed in, and we can actually see this in the background. There, I've typed in that crazy URL, and instead of getting the DNS error response, I got an IP address that resolved to it. That is not what I expected. Now, in the area of annotation, besides the trace file annotation, and this is where we would annotate. When you click on that bottom left-hand corner button, you would enter your trace file comments here. and then you would click Save Comment. This area right here is the comment area for the entire trace file. But we can also put in annotations for individual packets. And this trace file is very heavily annotated. You can see frame 1, frame 2, frame 3, 5, 7, 12, 15, 18, 29. I use this to teach students. I send them home with a trace file and say, it's annotated. I want you to look through the annotation of the term packets and walk through what my analysis was. Here is a great way of seeing all of the annotations in a trace file. Let's say you have students that go out there and you tell them, okay, put your comments in. To put a comment into a packet, let's say I looked at this packet right here and there was something interesting about this packet. We can right mouse click and choose Packet Comment, and then this is my comment about this packet. Type in our comment and say OK. Right. We can see that there's a packet comment area. I just noticed a bug right there, by the way. It didn't refresh right away to show me my comment. I will submit that bug. I'm the #1 bug submitter for Wireshark because I work with it every day, all day long, and so I keep a master list of all the bugs. So here is my comment about this packet. And what's interesting is when you have your students go out and annotate trace files and send them back to you, you could always go down here to our Capture File Properties dialog button, see all these comments. But another thing you can do is you can right mouse click on the actual comment inside of a packet and say, apply this as a column. Now I've got a column here that will show me all of the comments in this trace file. If you want, you can sort this column so that all comments come up to the top together, so you can read through the various comments that are in the trace file. I'm going to get rid of that column because I don't need it right now. I'm just going to hide it. There we go. But if I really want to understand how the protocols work, the best thing to do is to start capturing my own traffic while I browse a website, or I send an email, or I initiate a Dropbox transfer. But it's like learning another language. Those of you that teach Wireshark, I am sure that you know that it is like learning another language. Okay, here's another little trick here. If you don't want that whole comment column there because it's really, really large, if you go to the line that just says Packet Comments, right mouse click and apply that as a column, you end up with just a check mark indicating that these are packets that do have comments in them. So you would never miss looking through a trace file and not realizing that, oh, it's got some annotations in there. That column makes it pretty obvious. That's one that I do, but I shorten that header. I don't want my headers to take up much space. So I'm going to edit this column header, and I'm just going to call it PC for packet comment. And now it doesn't need to take up nearly as much space there. All right, so that's annotation. Now, besides coming to my trace file directory to get trace files, there are other locations on the internet where you can get trace files. And my notes document will provide you with some other ones. pcapper.net is a great location because it's heavily indexed. So you can type in, let's say you're interested in DHCP v6 traffic. Let's just do a search. Okay, there's DHCP, a decline, a confirm, a release, a renew, a rebind, solicit, etc. So the nice thing there is that this is so heavily indexed that I can get just the packets that I want to get to show to the students. A lot of times I don't walk around with certain trace file formats. Another one would be NetResec. This is an interesting NetResec. There we go. This is an interesting tool set. Many of you are aware of Network Miner. Wow, what a great forensics tool that is. But also if you go into their resources section, you will see some PCAP files on the internet, and they're pointing you to all different locations. And since they primarily work in the area of security, there are lots of locations where you have trace files showing breaches or scans or things like that. They have some fascinating products also. I think this is an interesting company. All right, so what I want to do now is I want to do a demonstration for you dealing with, let me just put it in here. Okay, decryption. All right, if I go out to Wireshark and I start a capture, I'm just going to go ahead and start this capture, and I don't need to save that last one. And I'm going to go out to, let's go to ESPN. Oh no, let's pick something different. Let's say we want to go to Microsoft's website. There we go. I'm going to come back over to Wireshark and stop my capture. I'm going to do a very lazy filter that says frame contains, quote, Microsoft. I just want to know where the beginning of that process was. And since I cleared my DNS cache out before I came in here, I know that there should be some DNS queries generated for each of these sites I go to, and that helps me find the beginning. Well, there it is. I can see there's a query going out for Microsoft.com. There's an answer coming back. There's my quad A request looking for an IPv6 address, which, wow. Now that surprises me. Microsoft's primary website does not support IPv6. It came back with a start of authority response instead of IPv6. Okay. Now remember, I've got a filter in here. So I'm only looking at frames that have the word Microsoft in them. I'm not able to see the TCP handshake process and things like that. But I could see, I just said Microsoft.com. So I went out to a port 80, unencrypted. I want to hit Microsoft's website. I said, get me the main page, and the Microsoft website responded and said, hey, this has been moved permanently. And what it's doing is it's redirecting me to a secure connection. So here's the location it gives me. It says, hey, to get to Microsoft.com, you got to go through HTTPS. This is a redirection taking place. I go out and I do a DNS query for Microsoft.com. Again, I've just been redirected. There's the response coming back. And here is the actual connection to the Microsoft website. I'm seeing the TLS communications. I'm going to right mouse click on that client hello and just simply pull out that one conversation. And this is what drives people crazy with analysis. And students just, it's so frustrating because everything we want them to understand on communications, it's encrypted now. So how on earth are they going to understand anything above layer 3, above TCP? And yes, they can understand TLS from this, but what if we want them to understand the applications running up above? All those apps are now invisible to us because they are encrypted. So I'm going to show you how to get past that. And I have in the notes document for you, by the way, this is what the notes document looks like. It goes through what I'm demonstrating. It goes through the sites I'm showing you. But we are on step number 6 on the notes document. Okay. And what I'm going to do is I'm going to set up my Windows system to capture the pre-master secret files on my local system here, the client pre-master secret files. Then I'm going to go into Wireshark and I'm going to point Wireshark to the pre-master secret key file. And when I capture traffic, it will show up decrypted. I think F5 did the best job of providing in one document the instructions on how to set this up on a Mac, on a Linux host, and on Windows. But this is something that I teach now all students, and this is This is actually the first time I've taught it in a webinar. I've been teaching it in the private classes, things like that, but it's time to get everyone to understand how we do this. You have to understand how the apps work. You've got to have decryption set up before you do your capture. So I am going to set up Wireshark, and we're going to hit a site. I'm just going to close this trace file. I'm going to clean everything up here. I'm going to set it up on my Windows system. I'm going to point Wireshark to my decryption key, and then we're going to browse a website that we know is encrypted. So the first thing I'm going to do is hit the Start button on Windows, and I'm going to type in System. There it is. I want to go to the System Environment Variables. So we are configuring our operating system first to save the client pre-master key to a file. Then we're going to point Wireshark to that file to apply decryption. So in System Properties, I'm going to go to the Environment Variables. Now, this is where we make that decision of, do we want the environment variable, the decryption, to be applied for this user only or system-wide? Now, I have other accounts that can log into this computer, and I don't want them to be able to do the decryption. So my user that I log in with is called Lenovo. Very boring there, I know. And so I'm going to make it so that whenever I'm logged in using Lenovo, I can decrypt my traffic and see it in Wireshark. But if I log in by somebody else, I cannot. So we're going to add an environment variable. I'm going to click New, and I'm going to add the environment variable called sys_key_log file. And I'm going to point this to a directory on my local system. I know that I have a directory called keys. That's where I keep all of my RSA keys and all of my decryption keys. So instead of browsing to that location, I'm just typing it in. Okay. Thank you, Nicole. Nicole just gave all of you the link to download the PDF file. Don't get distracted downloading that right now, because I want you to watch these steps that I do. You need to make sure that you don't have a typo in here when you put the name of this variable. So it's SSL key log, and I'm going to give it a number here because I sometimes will just capture the key for this one browsing session and distribute those together rather than hold one master file with all the keys for all my sessions. I really want one for just this session right now. So I'm going to call this, SSL key log, and I'm going to put the number 9 in there, dot log, log. All right, so I'm going to add that, and there's my new environment variable. I'm going to say OK, OK. And now I have one more step. I have got to point Wireshark to that log file so it knows how to apply the decryption to my traffic. So I'm going to go to Edit and Preferences, and I'm going to go under Protocols. This is TLS that they're applying the decryption for. So I'm going to come down here in Protocols. I'm going to go down to the TLS settings, and here we are. There's TLS right here. And there's a section down here where it says pre-master secret log file name. I'm going to point that to D:. I could browse, but I already know the directory. Keys \, and it's going to be my SSL key log 9.log file. So the first step is we set up our operating system to capture the client pre-master secret file. And then we set up Wireshark to refer to that. And I'm going to say OK. Now let's do another browsing session, and let's go back to Microsoft's website. I'm going to start a capture here. And before I do this, I'm going to close Microsoft's website. Actually, let me stop that capture for a moment, because I really want to get rid of all my cache. I want to make sure that it loads this website from scratch. So I'm going to bring over my command prompt. I'm going to clear my ARP cache. I am going to flush the DNS cache. And in my browser, I'm going to go to Options and Privacy and Security. And I'm going to clear my website data. I don't want that Microsoft website loading out of cache on my local system. Okay. Now I'm ready to go ahead over to Wireshark, start the capture process. And I'm going to toggle over. There's all that Zoom traffic. And I'm going to go to Microsoft.com again. All right, I'm going to toggle back over. And let's make sure it worked. Frame contains Microsoft. And let's apply this. Ooh, it did not work. Let's just check. Oops, my alarm's going off telling me I need to stop talking soon here. All right, let me just check and make sure that I have my log key file created. I'm going to go over to my drive really quickly and make sure it created that log file. The only time I've seen when it didn't work is usually it's a typo on my side, or I need to reload the trace file. So I just stopped capturing, and I'm going to do a reload process, and we'll see if that clears some of this up. And let me go to my keylog. Hang on, I'm just on another window. I'm just checking my keys file. Make sure it created that keys file for me. And that's the problem. It did not create that keylog file. I might have put in a different name. It's always a typo. I'm telling you guys. System, let me just pop back over here. Environment variable, and there it is. And I just want to move this so you can see what's going on here. I expect to see a sys key log. Oh, that's why, typo. Yes, do you see that? I put SSL key log. That's me. Sorry, you guys. Well, you know, I don't want to hide mistakes because your students, you're probably going to hit that too. I can see that there's an SSL keylog before. I think I pointed to one name and I typed it in as the other name. Well, I'm going to keep it SSL. I'm going to keep it the way it was and check Wireshark. You can see it's got a match, obviously. So SSL keylog 9. Okay, okay, okay. Now I'm going to show you a trick here. This is how we quickly get into that TLS settings area. I'm looking at a TLS packet. Down here in this detail window, I'm going to right mouse click on the TLS section. Say I want to go to the protocol preferences. We can open it up. And sure enough, I typed it in system. This is where I always get myself in trouble when I type it in wrong. All right, so I got to make sure it matches. So I have it in there as SSL keylog 9, SSL keylog 9, D:\keys, yes, yes, yes. Okay, close that out. That looks like it should match. I'm going to say okay. All right, I'm going to hit a site, get rid of this. I'm going to go out and do another capture. If for some reason I can't get this to work, I will go back through my settings and get you a video showing you this is the way it is. It's just, sometimes it's true. I do typos. I do have typos. So. All right, so there we go. I'm going to come back over here. Let's hit my blah, blah, blah. Let's hit wireshark.org. All right, let's come back over in here. And we are going to say frame contains, Wireshark. Boy, there it is, and it is not decrypting. Huh, I'm gonna do a conversation filter. And wouldn't you know it, right when I'm going to show it, that it's not actually functioning for me? That is so weird. I've never had it not function properly. So I am going to make sure, and if anybody sees that I typoed on that, do let me know. And let me go down to my TLS settings here. /.
I think it's kind of
And I
refreshing
can
to
hear,
be an expert like you stumble the same way the rest of us do. And
oh, yeah.
the key
Well,
learning
and
being that sometimes it's a typo, and that's
so what I want to do though is I want to go through, I've got to make sure that we don't have a bug in Wireshark that's caused this problem. But I did go through this morning before the session, went through it, it decrypted fine, everything worked great, and I didn't hit this issue. Now I have not tried a number 9 in my log file settings. I've always stayed with the lower 5 and below. That is the first time I've gone up to that, and I don't know if Wireshark may have a bug stopping that. But what I would like to do is, if it's okay with you, Steve, and Karen and Nicole, I'm going to go through and record this in just a moment, make sure we don't have a bug, and if we do, I'll give you the bug number I submit. And then I will send you the instructions and a video that you can add as an addendum to this showing this process, because I think this process is very important for us to show the students how they can see this decryption. Now, I did put together for you a sample of a decryption system setup that has been tested and tried. One of the files that will be distributed to you is this TLS decrypt read file comments. And in here, I've given you my syslog or my SSL keylog 4 file, and I've given you a stream, an actual trace file on which to point it, just so that, I mean, these are the ones that, actually I don't have to record it because you've already got the files right here showing it. So this one right here is one that already has the log, and all you need to do is point it to it. Sorry, I have to point it to it. I can't, I'm going to be fanatical now about this, that how could you not function when I need you to? 1 second, because I know that you are a little short on time. I need to get out here. Let me get to my Steve directory. And wouldn't you know, I don't have it unzipped. Let me just unzip it here. There we go. I'm just going to point to it. Make sure I really don't have a bug in here. That would be, oh, come on, really? There we go. All right, syslog, SSL log 4, I'm going to apply it. There it goes. This is what we should see. And when that applies, that log file applies, I can tell you, you'll know right away. If you hit the wireshark.org website, it uses HTTP version 2. So you'll see all this HTTP version 2. That's what it should look like. And again, I'm going to go back and find out why number 9 did not work on that. But this is what it looks like. And from this point on, you just let the key file sit there and accumulate all the client pre-master secrets. And as you browse around, everything should be decrypted at that point. I know that we have to finish up, but there's one other thing I want to mention, and that is decryption from the RSA key. If you go back to the blog, there is a cheat sheet that I made for RSA decryption. Now, that means you're getting the key from the server. You're going and getting the RSA key from the server, and you're applying it to the traffic. So we can see there's the network forensics cheat sheet. And I'm going to open it up because in the back side of that cheat sheet, you have step-by-step instructions on RSA decryption. So here is the network forensics cheat sheet. And if you go to the back side of it, here is step-by-step instruction on how to use this RSA snake oil trace file and apply an RSA key to it. Now, as part of the handouts for this class, I'm providing you with the RSA snake oil trace file and the key file so you can play with this and set this up. Okay. There's so much to go through, and that kind of, I'm surprised that decryption threw me on that one. But there is one more thing I want to mention on the options for teaching in the class. There is a really great website out there that has scenarios for teaching forensic investigation, network forensic investigation. I know that a lot of you probably know about malware traffic analysis by Brad Duncan from Palo Alto Networks. He has got great scenarios out there and tests and challenges and all, but a lot of people don't know about digitalcorpora.org. And there is a fabulous one that you can get to, which is the Nitroba harassment case. I've kind of run out of time to go through that harassment case, but I would tell you that in looking at that case, I would recommend that you do a filter that says frame contains Lily. Look at the name of the target for the harassment case and bring up those files and start, or those packets, and start looking from there. You have some evidence to work from. Now, you folks can get the answer sheets to Digital Corpora. I cannot because I am not an accredited institution, but you can. And I have the link here for all of you to get your answer sheets for all of those wonderful, wonderful scenarios that they put online. They have host forensics and network forensics. And then on my notes document, I also have other tools of interest: Nmap, NetScan tools, Autopsy, Trace Wrangler, Security Onion. And I do want to finish it up by saying that the creators of these tools are going to be online at the Core IT conference that we have coming up. So Core IT is a free event. I am bringing in so many of my industry friends. I want to invite you. I want you to invite your students to come out there. There are 30 technical sessions taking place. We are doing open badging for the technology that's being taught in those sessions. We have the guy who created NetScan tools will be there. We've got Mike Kershaw, wireless interception guru. We have Andrew Lumen, who created Tor and now does investigations on the dark web. Andrew is going to be showing you some really interesting law enforcement cases. We have Saka, one of the Wireshark core developers, coming out there as well. We just opened registration last night at midnight. So you're the first folks I have told the registration link to. We are all going to be live on March 24th, but the event immediately goes into on demand until March 30th. And I will be there through the whole time in the chat room, talking with people, sharing stories. And here, one of the things I gave you in the handouts also is the virtual event center. What's being covered in each location within the virtual event area. One of the things I want to make sure all your students go and get is the mentor manual. It sits in the exhibit hall in the student union booth. And it is advice from my existing peers in the industry on what we would have said to ourselves when we first started getting into this industry. What skills would we have told ourselves to master? What are the hardest things we've gone through in the industry? What are the moments that make us wake up and realize that we need to change the way we are working within the industry? So it's all these areas of advice from many luminaries in the industry to, people like me who just sit and teach protocols and packets. What have I learned through my 30 some odd years? So I know that we're getting down last 5 minutes. I'm sorry. I always run.
This is great. No,
over.
Use every minute. Unless we have questions. Anybody has questions right now, like to type them in if you haven't already, please do. I think that we've got an abundance of resources from Laura, and this is terrific. I'm looking forward to that virtual. So that's not a physical location. It's all virtual then. Is that how that? That
is, yeah.
You gonna have little avatars walking around or anything like that, or you skip that stuff?
We stayed away from that. We want it to be as streamlined as possible for the experience. And because I do traffic analysis, I know what it takes for avatars to be moving around your screen, and we just don't need that at this time. At some point, we may end up being true VR, but we're not quite at that point.
Well, I think the layout here gives the sense of being in a place, and of course you click on those locations, and then I guess you go into a video link or some kind of connection to the actual programming. Is that how it works?
Yeah, what happens is you basically enter and you have a choice of all these different locations you can go to on a menu bar. And then once you click on one, like let's say you want to go to the exhibit hall, you click on the exhibit hall, then you're going to basically be looking at a room that has all these different booths in it, and you can choose which vendor's booth you want to go up to. Or of course we have the student union booth in there, which is just going to be phenomenal with the mentoring taking place in there. But you also have the option of going into the session rooms. And when you go into the session rooms, once the first day is completed, then all of the sessions are on demand in that room. You can skip around to any of the sessions you want to go to. You take a session, and then you can click to go to the Open Badge Quiz Center right away. So you can take your quiz on that content and achieve your open badge for that session. I think we are giving away 50 open badges during this one week. There are 50 different badges that you can achieve, covering everything from, of course, performance measurements and pen testing to, encrypted DNS and, autopsy for host forensics and things like that. So it's quite a range.
That's good. And are these sessions going to be recorded at the virtual event?
Yes, everything is recorded after day one. So for example, the minute my session is done at 9 a.m. on day one, it immediately pops over into on demand. You don't have to wait for processing or anything like that to happen. It is immediate that it shows up as anybody can pop over into it and go and see it now. And for the rest of the time that it's open, everything is on demand.
Well, this is a huge commitment on your part to put this on. I think it's terrific. I'm just kind of curious. I guess the question is, what's your motivation? But what brought this about? And why are you doing this particular event?
A number of factors came in around the same time to make this happen. I've gone to a lot of the big industry conferences, the Cisco Lives and RSA conference, and number one, they are extremely expensive for the attendees, incredibly expensive for the vendors. And at the same time, getting involved in your group and the teachers out there in colleges and the professors in colleges, and working on a National Science Foundation grant with Ann Baylor, and listening to the hiring professionals out there and what they say that next generation needs to be equipped with to be hired, and then listening to what's being taught in schools and things like that. It was fascinating how much of a push there was towards the core protocols. Bring us kids that understand the core protocols, how TCP works, and the core products and tools out there. Show us how they understand these core tools. So we got the idea of, okay, let's put something on that covers what we believe are the core set of skills, knowledge, and abilities that folks need. We've got vendors out there and incredible amounts of talent out there in teaching these things. Let's put them together and let's start reaching out to this next generation. Most of the folks that I hang out with have gray hair, and we need people. I need somebody to replace me as a person that travels around the world and analyzes networks and does forensics and things like that. We need this next generation to come in and fill our roles. And this is a way to reach out, bring them in and introduce them to all of my friends, mentors in that industry, and make sure that we can help them get these core skills while having someone to hold their hand through the process and make sure that, we can help them get in here.
Well, we're certainly glad to help you promote this event throughout our system as well. I'm sure Nicole and I can find a way to have we put out that new IT-focused newsletter yet, Nicole? Perhaps we could include a blurb and links on this as well, if that's okay with you, Laura.
Absolutely, please. I encourage all of you to invite your students, invite other faculty members. We believe we will have between 10 and 16,000 people in this event through that week. Mm-hmm. And we really do want a strong student showing, because that's why we're building the mentor manual document. And we've got some pretty fascinating characters that are coming into there to just sit around in the student union booth and answer questions. You know, how did I get into coding? What are the 3 best coding tricks I learned in the industry? What makes me angry when I'm coding, and how do I get past that point? What makes me frustrated? We've got so many people that are willing to mentor and give advice that I think it's a great opportunity for the next generation to really tie in and have an industry mentor that you're connected to on LinkedIn or something.
Mm-hmm. Yeah, no, I really appreciate and applaud your purpose and your goals in doing this, and we'll help every single way that we can. You know, I'm often greatly humbled by the fact that out of we have 114 or 15 or whatever it is community colleges and 2.5 million students, and our biggest challenge is getting the word out to all those students about different things that come up. I mean, true, some of them only are not interested in this discipline, obviously, but many are. And so that we'll try to use our messaging system to get to them best we can. Thank you very much. Any questions for Laura? We're about 3 minutes over, and I just want to make sure I'm looking at this. I'm not seeing anything. Basically, what I'm seeing is a lot of chat comments saying, thank you. This is fantastic. Is it recorded? Yes, yes, yes. It's recorded, and it will be on our website, the transcript, as well as although the transcript people might have a little bit of a problem with some of the technical things here, but we will have the video and everything there. So it's a great resource for you. And thank you, everybody, for showing up and enjoying the seminar. Thank you, Laura, very much. You're an excellent presenter, and it's always a refreshing and nice listening to you. With that,
thank you for the opportunity.
We'll wrap it up. And thank you all, everybody. Take care.